These are in listen-only mode.
Good morning, everyone. This is Woody Cash. I'm on the board of directors for the SCTE Golden Gate chapter, and I am. We're going to talk about amplifier training, more specifically mid split and high split, which is different from us, different from what we've experienced in the past. So there will be some new things and also some repeat of things you may already know. But we have a great speaker today. We have Richard Hager. He is a well-experienced person to talk about this and very knowledgeable. And I think you'll be filled full of knowledge today. Also, just a couple notes here. If you have any questions along the way, please put them in the questions box. I will pause Richard periodically and read them out. And before we get started, I would just like to say welcome everybody, and especially the Golden Gate chapter members. But also we may have members on from Lake Michigan chapter, Buckeye chapter, Indiana chapter, and the Great Lakes chapter. So for all of you guys, welcome. And also, in addition, I wanted to talk just a moment about benefits of the SCT, but I'll keep it real brief. If you want to see a repeat of this presentation along with many others, if you're a member, you can get into the webinar archives, and then you can replay this, or you can play many that you haven't seen before. So with that, I'm going to go on mute, and I'm going to turn it over to Richard. Richard, thank you, and let's go ahead and get started.
All right. Everybody hear me all right?
Yes, I hear you loud and clear, Rich.
All right. So my name is Richard Hager. I'm a technical support engineer for CommScope. Previously with Motorola, General Instrument, Aris, Gerald Electronics, Gerald Communications. So I go back quite a few years with these amplifiers. If there's anything you guys have questions about, just understand that, it's something I'm, very well versed at and probably can answer, most of your questions. If not, we'll get back to you on anything that comes up. I do want to point out though that, we're not really, trying to be vendor specific here. Or MSO specific. So you'll see slides that may, lead you to believe that, but all I'm trying to do is get across the key points that, that I was asked to present, which is basically, understanding, different band passes, how to set up the amplifiers correctly. And this goes for any vendor that's out there. So with that, thought I'd start off with some amplifier fundamentals, and only primarily because there's a lot of things that are overlooked, like stinger length, it has to be accurate. So for whatever vendor product you're using, make sure that you're following the guidelines from that particular manufacturer. And we want to focus in on what we're trying to do, and that's the medium that we're delivering the a lot of the content through, which is the coaxial cable. So because we're dealing with amplifiers, this is vitally important. When you look at the cables, you just need to understand that it serves two primary functions, which is a transmission of the signals, and it also carries the power. So we don't want any kinks. We don't want anything to happen to the sheath. We want the stinger lengths to be correct, and we want the dielectric to be dry. We don't want things laying in the back of the truck when it's raining, or back in the bucket where water tends to collect because there's no drain or anything in the back. What we're really trying to accomplish is what we call unity gain. It's the net gain from station output to station output, and it's generally set up for 0. So any design that occurs, you need to be mindful of those design prints and what they're actually trying to tell you. And you'll notice that if you look at the tombstones. It'll, pretty much tell you what the outputs are supposed to be. Inputs, those are going to vary based on, the length of the coax in front of the amplifiers that precede, the amplifiers. But you can see from this diagram, what we're really trying to accomplish is, 47 out here, 47 out here, 47 out here, and 47 out here. And the reason why I mention this is just simply to give you an idea that there's no set number here, but it's based on whatever your design team decided. What the playbooks say, how they want you to set up the amplifiers is vitally important. So if you work for Altice, you work for CommScope or Comcast, Charter, any number of other cable systems, you want to make sure that you're following your own guidelines and system level requirements. On the return, we basically are looking for the same thing. We're looking for an ejection level. Don't remember this number. It's just a number that we're using as an example. But you can see there's 18 going into each amplifier here in red. And all we want to do is just maintain unity gain in the return path. So make sure you're following the design prints. Not going to go over this too much because this is vendor specific, but all amplifiers have, a rubber gasket, and they also have a wire mesh gasket. And you want to make sure you maintain that you tighten up all the bolts according to, whatever vendor product you're using. Because I work for CommScope, we also sell equipment that, came from the Motorola side, from the Secor side, from the Magnavox side, even going back to ADC. There were some amplifiers that were built, years and years ago. But I've been involved with pro services, so I've had my hands on other vendor equipment, just simply because we were making money from doing the installation, similar to what business partners and contractors do for the particular MSO they're working for. Ordering matrix, everybody's got one of these. You want to make sure you're familiar with how they designate the date code, how they designate the configuration of that amplifier. It'll tell you how that unit was built. And that varies from vendor to vendor. A lot of the components, like your cable equalizers, here we're showing EQs designated with cable equalizer, value 12, this cable simulator 12, return EQs, return pads. Not all pads and EQs fit into other vendor equipment. Some things are common, but what you have to worry about or concern yourself with is pin length, pin diameter, and whether that product is something that the particular MSO that you work for has designated as being something they want you to use. I've spent a lot of time all over the world, and I've run into issues with pin length, pin diameter, and just form and function issues, and we want to try to stay away from that.
Hey, Rich, I have a question, if I may.
Sure.
On the ADU, is there a easy way for a technician to identify if that's a QAM ADU or a analog ADU?
Good question. It should be in the designator or the configuration of the amplifier, and that's usually found in the manuals. In this case, you can see this is a CommScope amplifier, so it's a MB120, and it's 5 to 85 on the return. Right here you have a QAM ADU 711, and if it was an analog, it would say A here. 609s, of course, would be a Q. There's not too many people that are working with those right now. Most everybody's using, even in the high split, we're still sticking with, for now, QAM ADUs with 711 pilot, so it'll be a QAM ADU. The main difference between a QAM ADU or a automatic drive unit or AGC is, I can't speak to all vendors, but in this case, analog ADU, if you lose the pilot at the head end, generally the amplifiers ramp up and try to find the pilot, and it causes some real issues. With a QAM ADU, in this particular case, if you lose a 711 pilot as an example, the ADU itself will go to where it would be set in a, sort of like a manual mode, and keep the amplifiers all running, where they were manually set up until the pilot's restored at the head end. Of course, if you have a suck out at 711, your overall frequency response is low at that particular point. Just make sure you also, keep in mind what that level is supposed to be at 711. A lot of people concern themselves with, low and high reference carriers, and I use the word reference because that's what we, traditionally had called them in the past. The pilot is not the high and low frequency; it's the pilot carrier, and that carrier needs to be maintained. The head end team needs to make sure it's going out the right level, it's hitting the transmitters at the right level, it's coming out of the node right level, and through all the passives, getting from amplifier to amplifier, that it's not being affected by the coax. For whatever reason, design issues, bad or old cable, things that need to be, repaired. Just be mindful that you want to really make sure you're looking at whatever pilot carrier that you happen to have on your system, that what that frequency is, what channel number it is, and that, if there's a problem with it, you contact somebody and let them know, hey, this thing appears to be sucked out or bumped up, and you can tell that it's being affected. So you also want to look at upper and lower adjacents, to that pilot level to make sure that everything's roughly the same. Hope that answered your question, Woody.
It did. The only one, there's no way to tell if you're in the field, you don't know what was ordered for that particular device.
Most of the time there's a sticker or a stamp or something on the cover that it will let you know.
Yeah.
And then also, if you look at the configurator sticker on the side, and I probably should have elaborated a little bit more, you'll see something that looks something like this. And that's, in my experience, that would be from any vendor. So it would tell you, like for this number 9, and if you looked it up in the manual, it would tell you that it was a 711 pilot. But a lot of the equipment we put out, regardless of, its vintage or legacy, will also have some sort of sticker on on the cover itself that tells you that it's, a 499 and a quarter or a 711 pilot that's necessary.
I've certainly seen techs get confused with between the 499 and 711. So yeah, it's always good for technicians to take a look and make sure they're looking at the right frequency for their pilot.
For some reason I got 2 of these guys going on. Let me get rid of one of them. I might not be able to use it. I'm just going to use my pointer for now. For some reason, I'm getting 2 red dots on my screen. Real briefly, at least in the the traditional legacy Motorola GI Gerald type product, we would put a date code on the unit, and this is also important if you're going to call in. Get familiar with the how the other vendors designate that. It's usually called out in the manual, but it'll tell you what month the unit was built, what year it was built, and oftentimes what factory it was built. So in this case, this would be the 5th month or the 5th letter in the alphabet, which is E. So it tells you it's May, and it's the year 2023, and it was built in Tijuana, Mexico. So there's stuff here that doesn't seem like it's all that important to most people, but if you're going to call in, you're going to have you've got a concern with the amplifier. It's not working the way you want it to. There may be some kind of database that each vendor maintains that tells them on that particular year and model we had this issue, or we identified it as a non-issue, and this is what we did to correct it. Either by training or documentation that we send to the customers. I do want to, now that Woody mentioned the ADU, I want to make sure that everybody understands that on this particular device, which is the the CommScope brand, this pot is like a 20-turn pot, and all you're really trying to do is get the amplifier set up, correctly in the manual mode, and all you're going to do is move a jumper or a switch, depending on the vendor you're dealing with, and basically adjust the ADU, QAM ADU or the ADU to the same level that you set up the amplifier in the manual mode. So that's all there is to it. If you think about it too much, or you turn this pot too much, you're probably going to break it or cause some other issue. So just be mindful that all you're really trying to do is get it set up manually, move it to the automatic mode, regardless of vendor, and then basically just touch this control just enough to marry up the levels that you set up, and make sure that they're the same as they were in the manual mode. And usually your reference, either the pilot level or the highest carrier on your bandpass. So get very familiar with using the proper terms. If you're going to call somebody on the phone, you say, I got 17. You need to make sure that you're saying dBmV, or I have a difference of 17 dB between what I think I have, or my slope is 17. Make sure you're talking in common terms that everybody understands, so they're not trying to scratch their head about what you're talking about. Make sure that you're communicating correctly on the radio or telephone, or what other device you're using. Here's just some accessories, and I point this out simply because of what I mentioned earlier. Because we have, at CommScope, we have several different vendor models. A lot of the accessories may be slightly different. So between vendors, they can be different as far as length, overall length, pin length, diameter of pins. A lot of that stuff has been sort of standardized over the years, but we still want to make sure we're maintaining and using the proper equipment in each amplifier or node. Features, I won't go over this too much other than to point out what I believe we should understand, and that's the diplexing of the amplifiers. So when we mentioned expanded return bandpass with support to 204 for high split, it would be to 85 and above. I think it's channel 31 and above on mid split. You just need to understand, what area you're working in, what your design print has, and that you're installing or maintaining the proper amplifier for that location. In all these different areas of the country, all over the world, in fact, you may have areas where you're still at 750 or 870. You're buying 1.2 gig amplifiers and you're setting them up at 1 gig as an example. And that's primarily what most MSOs are doing right now, because a lot of the premise devices are not available in those higher band passes. So just be aware of what amplifier you have, that it has the right band pass, and you're installing the right equipment and maintaining it correctly. Make sure you're looking at what tools you have. Make sure you have the right tools on hand, and then understand the torque on all the bolts that tighten up the lid to the base. You also want to make sure that you're not over tightening cable connectors. You want to make sure that your strand and strand clamp and pedestal mounting stuff is being done correctly. You want to get a good ground based on the design for the the powering system and the grounding system for that particular area of the country. Make sure you're following all the guidelines for whatever MSO that you're working with. We certainly don't want an amplifier or a node to fall on somebody's head. So, make sure you're tightening these things up adequately, not just by hand. I can tell you there's not many people on the whole entire planet that can tighten a bolt to 120 to 144 inch-pounds on all the bolts on this particular amplifier I've been pointing out earlier, which is the mini bridger. Not all vendors use the same amount of torque on all their bolts, so make sure that you're looking at all that as you approach each amplifier type that might be out in the field. You know, some systems are still upgrading, and you know, you may have areas that are, you know, Cisco. You may have areas that are, you know, any number of other vendors. You know, Motorola, Magnavox, Ecor. Just make sure you're following the guidelines for each each individual product, and you know, try to maintain a library and, you know, keep the manuals close to your, you know, possible usage of them. You want to have those available to you all at all times. Opening and closing lids, you just want to make sure that, you know, if the amplifier won't open, that you're not forcing a screwdriver into the, you know, the top to crack it open, because there's a vacuum. So a lot of times you can just use a nut driver, loosen one of the port caps, and you can actually relieve the amount of vacuum that's inside. You'll hear a hissing sound, and, you know, then the amplifier will come right open. Housing gaskets already covered. Just make sure they're maintained. There's no leaves or anything, you know, across them. In this example here, you can see that both handles for this particular amplifier are laying over your gasket, and you don't want to try to cut, you know, cut your gasket in half because you left these, you know, these handles in place. All the different vendors have, you know, different rationalizations for, you know, how you maintain it, but most of the time it's just making sure there's no leaves, debris, that kind of stuff that can actually allow water to egress into the amplifier.
Hey, Rich,
Just make sure
before you get away from housings, I do have one comment.
Okay.
I once took a look at our repair costs for amplifiers, and the costs. Well, let me just make a comment first. Amplifiers, from when I started to now, they're very reliable device, but they're not very reliable when they get water in them. And I looked at the repair cost of amplifiers due to water damage, and it's quite significant. And even more significant is the devices that are unrepairable because of water damage. So just a little effort on the front end will save you a lot of grief on the back end.
Yeah, one other thing why this thing is open, you can see that there's a power supply in the lid of this amplifier. And, you know, like a line extender, a lot of times the power supply will be underneath. Recently, we had someone ask us, you know, can we use old JLX, you know, which were Gerald amplifiers. You know, I started with Gerald back in 1985. You know, I was a head intech at Cox before that, and TCI. I was, you know, I did all things for all people back then. But the one thing you need to understand is if you're going to mix and match like housings or lids or what have you, make sure that this is something that's been, you know, authorized and okayed with your corporate or local authorities to make sure that you're not mixing and matching or taking any shortcuts. And the reason why I bring this up is because you want new gaskets. You don't want to, in this particular case that was opened a couple days ago, they were asking if they could use an old base and an old lid and, you know, just install the new module. And what we come to find out, you know, based on my experience, people all over the place were calling me and asking me about it. And I said, well, that lid is a lower profile and it will not fit on the base of that unit if you put a brand new 1.2 gig amplifier in there. So make sure the equipment you're working with is, you know, it's supposed to be used. A JLX or a JLE amplifier are from the 80s and 90s. They might have even got into 91 or 92, but for the most part, in you know, the case of like the line extender, they went from what they called a JLE, JLP, JLX, and those all had lower profile lids on them. And then when we went to BLE, the module was a little higher in height, you know, as it sat inside the base. And people were trying to force a brand new amplifier into an old housing and then trying to use the low profile lid, and then they were complaining it didn't fit. I don't bring this up to, you know, belabor anything or make people feel bad about anything, but just make sure that you've got new gaskets, you're buying, you know, brand new equipment. Most of this equipment will last 15 to 20 years if you maintain it correctly. You certainly don't want to put it into an old housing or an old, you know, put an old lid on it if it's not going to, you know, perform correctly. The other thing is that the cavity that's created when you use a lower profile lid will eventually cause more oscillations within that unit. And you may have to, do some special thing to those lids or say like the cover on this particular amplifier just to break up those oscillations. So it's no different than what we, I was a microwave technician before. You don't want your klystron to have a big dent in it or anything like that. It changes how the amplifier operates and what potential oscillations could occur. So make sure you're maintaining your system correctly and you're using the proper housing, lids, amplifier for that particular location. One of my pet peeves. Sorry about that. Port caps, just get familiar with whatever vendor product you're working with. All this stuff is, outlined in the manuals. Three of my favorite letters are RTFM. Read the fantastic manual. Get very familiar with what you're using. Don't try to create something it was never designed to do. RF trays, they all have hold down bolts. Want to make sure you maintain those. You don't want to use drills on any of the vendor equipment that I'm familiar with. So you want to tighten those up to, whatever spec necessary. Generally, it's just hand tight. Just make sure they're nice and snug and they're all forward tightened up. They're not missing or anything. And then there's a lot of cover screws on a lot of these amplifiers, and especially on this one, there's, I think, 13 or 14 screws on this one. And those screws are tiny. There's no reason to take the lid off, and unless you're going to change a diplex filter or something and, some kind of upgrade, and you're probably going to want to do that on a bench. You're not going to want to do that in the field. These little tiny screws right here, and I've taken thousands of them out, get lost real easy. And they need to be maintained and, inserted, not stripped. You got to get a #1 screwdriver to take them out. It's just something you don't really want to do unless you're really, in a controlled environment. And this is just what I was talking about module cover integrity. Just make sure, you're not creating possibility for any kind of oscillation, peak to valley response issues or suck outs. And all that we talk about with oscillations, having, not a good path for that forward going signal or return path signal. And then part of that signal gets back and returned back to the input again. And that's how these oscillations will cause those, generally the output hybrids, to burn up. So be very mindful of that. On this particular amplifier, which is the mini bridger, it only fits into the housing one way. So again, if you have vendor equipment, make sure that you're not trying to do something the manufacturer, wasn't expecting you to do. Generally, we tell people right offhand that they do need to make sure that the, port #1 is on port #1. This port #3 right here, you can see there's this ridge. I've had people try to show me that they can put the amplifier in correctly, and they just simply busted the module. These inserts are pretty, important. On the mini bridger, in this particular case, it's a red insert, for where your coaxial cables come in. Make sure the pin length's correct. Make sure you have the proper band pass. These amplifiers expect red to get to 1.2. The line extenders will be purple in color, and you want to make sure that they can actually handle the load that down the road you're going to hopefully get to 1.2 or beyond.
Hey, Rich, can I pause? Can we pause for just a second? We do have a question.
Sure.
So the question is, what is the tightening procedure for the lid since the two bottom bolts don't need to be tightened?
The two bottom bolts need to be tight, and you need to loosen them up. If you're on if you're in an aerial application, don't go crazy and loosen them up too much. Like you probably don't want to use you can probably loosen them up with a torque wrench and then loosen them up a little bit more. What you want to be able to do is shut that lid and make sure it's flat up against the top of the unit as well as the bottom. So it's a good question. I
think I remember, at least on some nodes and amplifiers, the bolt tightening sequence is actually marked on the housing, like bolt number 1, number 2, and so forth.
Right. So in this case, you can see these 2 bolts right here. If you don't have those loosened up, what you'll get, I'm going to try to pull this off. You'll get like a clamshell effect. So if you're looking at the, the base of the unit, when you go to pull this top or this lid up to the top, you'll end up with this clamshell effect from the side as you look at the amplifier. You really don't want that. So you want to loosen these 2 bolts up, not to the point where they're going to fall or hang from this cord right here. And make sure that this surface meets up with this surface without a gap. And then as far as tightening the bolts, I think we have a slide here in a second. I'll show you that in just a few minutes, I believe. These on the particular the mini bridgers, they're all stamped with 1, 2, 3, 4, 5, and 6. Street access. I don't know how many systems are doing this, but you can flip up the amplifier and move or loosen up the hinges a little bit more. And you can see that everything on this amplifier on the left-hand side, all the writing is where it should be, or the way that we would expect it to be, looking at it. Let me see if I can get this the pointer to work. It's not going to let me do it. So just look at the one there, nearest to the amp. So all the writing on this particular unit, so it says Eris here, says Eris here, everything is, as you would read it, as it hangs from the strand. Over here, though, we've basically taken the lid and, you can see that the lid is actually upside down now, and also the amplifier is upside down. What we don't want to do is create that problem that I mentioned earlier with, trying to put the module in back, upside down to get street access, when your connectors are not, basically the same way, or you don't want to, or you're not having to use a cable long enough to reach the other, the other side. Just depends on what market you're in, what, MSO that you're working for, on how they feel about street access and, being able to flip the amplifier upside down and being able to basically make number 1 down here. I don't know why I got 2 of these darn things. Hold on a second. Went crazy on me. Let's get it back to here. I'm going to try to get rid of this double pointer thing here. So what we're trying to avoid is, having people try to force the module into the housing where it doesn't really fit. So use whatever recommendations. Not all customers like the idea that they want street access with this particular model of amplifier. The guys I'm working with in the Houston market, they'd rather run a longer cable and run it to the other side. So the other reason we're concerned about these seizure mechanisms is there's some really older equipment out there that dates back into the 90s, early 2000s. They don't really work very well with this these amplifiers, these new 1.2 amps. So at least in the Comcast world, in tier 1 and tier 2, they expect you to basically remove the amplifier of the housing and replace it with a new housing and new amplifier. And that's usually how they come out of the box. We do sell the electronic package separately, but at least in the Comcast world, you're going to find that they expect you to, cut out the old amp and put in the new amp. And that's called out in the playbooks. Anybody from Charter or Altice or any of the other companies, just make sure you're following the guidelines for your particular system or corporate edicts. Port entry connectors, just make sure the pin lengths are right. They're not the same from vendor to vendor, not even from product to product, you know. So just make sure you know what the number is supposed to be for each amplifier or node that you walk up to. And just make sure you're tightening up the connectors, you know, with the proper sequence. You don't want to tighten up the screw and then turn the back nut and then, you know, twist up the center conductor. On this particular amplifier, there are cut gauges. I've seen a lot of other amplifiers that have cut gauges. Just make sure they're correct, you know, that, you know, something hasn't changed from housing to housing. From if you're using older housings, in the Comcast world, of course, they're going to be, you know, replaced. Other vendors are choosing to use, you know, whatever housing is still available to them and just swap out the module. And they, again, just be cautious and making sure that you understand that some of these modules were never intended to be in some of the older housings. Power supplies, pretty common stuff. Electrolytics in these amplifiers. Again, when we're talking about older equipment and using older housings, a lot of times they have, you know, in this case, there's an older power supply in the lid. Want to look at the date code if you're going to use the older lids, and just understand that, you know, roughly probably around year 10 into the field, some of these electrolytics, especially out where I live in Arizona, they dry up and they don't do the filtering job they're supposed to do. So a lot of these power supplies will fail. One other thing, you know, that's probably, you know, worth noting, I've been to a lot of sites and a lot of places. I've been to every state in the country, been to about 40 countries in the world. One thing that always occurs is their operating budgets and their capital expenditure budgets don't often, you know, made up very well. So what'll happen is you'll send a unit back for repair because the power supply failed. And depending on who you're working with as a repair house, they're going to repair and replace the components that have failed. If there's several electrolytics in there, you probably want to talk to them about replacing them all, or you're just going to replace the whole lid, you know, with a new power supply, which would be my recommendation. You get new gaskets. It's just a good technical practice, you know, to follow some sort of guidelines as to how you want to approach old housings, new housings, older power supplies, newer power supplies, and, you know, not continually send product back to a repair house that's just going to fix whatever they're charging you for, you know, delivery of the product. You're shipping the product. They're going to, you know, evaluate the product. They're going to charge you for that evaluation. They're going to repair it, and then they're going to send it back. You probably could have bought another amplifier by then, you know, if they're a certain age. And always understand, you know, what your warranty, you know, involves. So most of the amplifiers we sell have a 5-year warranty. Other vendors, primarily the same. You just want to make sure that, you know, you're not giving away, you're not sending it to a repair house before it needs to be, you know, sent back to us for, you know, any vendor for repair, you know, free of charge kind of thing. Shunts, on this particular amplifier, we send them with all 30 amp shunts. If you burn up a 30 amp shunt, you know you got a direct short somewhere in the plant. You need to correct that right away. These are, we send these out with this particular amplifier and the line extender that I'll talk about later, with 30s, just so you can direct the power through. If you have a local physiology tree that you follow, make sure you're following it. Smaller systems are generally better at it. Larger systems, if the product goes back for repair, or you know, you got one in your truck and it has 30s in it and you're using 20s, and you take that one out, you send it back for repair, you put the new one in, you know, are you going to swap the fuses? Is it going to go back to, you know, a repair house that's going to put 30s back into it? Just make sure you're maintaining whatever, you know, practices that you want to, and make sure they're well documented, so that you're not mixing, matching, you know, your physiology tree all over the place. You know, so back in the day when we had 40 amplifier cascades, me and Woody are very familiar with those. We talked about it the other day. You might have your trunk or your super trunk amplifiers with a certain fuse, your distribution amplifiers with different fuses. And as you got farther and farther out in the system, you were using, a different size fuse throughout. Just make sure you're maintaining, whatever practices that have been, documented and given to you as a guideline to make sure you're doing the right thing with fusing. Under the cover on most products, there will be a F-Tech surge protector. These are designed to take any kind of overvoltage to ground. So, and it's also for your personal safety. So if some transient voltage comes down on the strand, provided it's not a direct lightning hit, you want that that power, that voltage to go to ground. So just make sure you're maintaining, whatever grounding system, your particular area needs. There's, all kinds of NEC codes along with, local codes, and then recommendations by your, MSO as to how they want you to maintain the ground plant. It's for your personal safety, and it's also for the safety of the equipment. And here's a whole, thing on bonding and grounding. On this particular amplifier, there's some things where you can shut off a, one of the ports. In this case, it's port 2. Other vendors may have a very similar potential for, being able to shut one of the legs off and, reserve some kind of power. That would generally be called out in the, the print, and it would probably only be used in like a rural area, way out in the country somewhere. Port 2, just make sure you're following, the recommended terminations and stuff if you decide you wanted to turn that one particular port off. And each vendor, is probably slightly different. So just make sure you have a copy of the manual in your hand. No mystery here, because I'm going to show you, what's underneath the cover. A few things have changed. This board right here has changed slightly to where the handle is in the middle and it's got a plastic dome over it. So when the handle was here, a lot of times when you pull the pad out, the board would lift up. The other thing that's different, recently I just saw a Comcast setup thing where they were actually taking this board out and replacing it with what we call a linear board that goes in the same location. Most all the new ones come with the new linear board, and there's no need to, change them if they're already done. So another reason to get familiar with the date codes. Closing the lid, as Woody was pointing out, we have a tightening sequence, and you can see it's 1, 2, 3, 4, 5, and 6. But also make sure on this particular amplifier that you loosen these bolts up so the top of this lid lays flat, as you shut it. Block diagram, this is pretty common for all vendors. You've got an input attenuator, place to do some equalization. In this case, you want a flat input to like a, in this case, like a mini bridger. Each vendor has a different name for this type of amplifiers. A bridger amplifier would be, pretty common. There's some stuff under the cover. It's designated as, restricted access, or everything in gray is, considered accessible. This PEQ used to have some controls on it, but there's a new linear board in there that has no controls on it. All the stuff here is under the cover. There's an attenuator or thermal attenuator. It'll, adjust itself over temperature if you're in manual mode. A gain, there's 2 different gain stages here. There's one on the input, one in the mid stage, one on the prior to the output stage. And these are primarily open-ended amplifiers, and they're, what we call push-pull. Now we're using mimics, but they basically operate the same way. You can see there's a splitter that allows us to get one output port on port 2 on this amplifier. Other companies, do something very similar. There is a place for an output attenuator. Just make sure you're following the practices that are in the playbook for each, area that you work in. But these stages right here, these two stages right here are actually power double stages. They'll give you 3 more dB of output. So if you lose half the power or 3 dB, you'll, like if you've got say 49 on, this leg here, but you've only got, and you're only using 2 ports over here, say you're at this test point right here, so these would be equal. And these are 3 dB difference as far as what you're reading here. It could be because somebody stuffed a pad in here, or it could be because somebody, hit the amplifier with too much level and burned up half the stage, one half of the stage of this 3 dB gain amplifier, 3 dB additional gain amplifier. Hold on a second. Hello. My dentist. This one goes straight out to port 2. This one gets comes down here. You can see that it has like a little bit of a U-turn to feed the gain circuit for your automatic gain control or ADC. Most amplifiers do the same thing, different vendor manufacturers. This particular amplifier goes down to a high split diplex filter. Same here at the top for port 2. This is for port 3 and 4. The high side takes care of the forward going signals, the low, for the return path. There's a 20 dB directional coupler, so you, in this case, to verify your output levels are correct. And then you have a position here on this particular amplifier where you can pick a directional coupler that can be an 8, 10, or 12, or you can have a splitter installed here, and it would give you 2 equal output ports. Now, understand that the design team has to determine, how they want that set up based on the, the passes or the taps after this particular amplifier on those 2 ports. There's also an amplifier now. Comcast is buying some of them. I don't know that anyone else is right now. I think a few people down in South America that I've talked to, where we've taken this place where you can put a splitter or directional coupler or a decision whether you want port 3 or 4 with a a small jumper to turn port 3 on or port 4 on, and they put a splitter here and they give what they basically a balanced output from all 3 ports on the downstream. But again, the design team will know that. You just need to make sure you have the right amplifiers in place. I got a call, I think it was from Utah, and they had taken delivery of some of these units, and they were just asking me, how's this set up? And you don't set it up too much differently. It's just your output levels are going to be different. You just don't want to mix and match those in your system. So know the difference between a amplifier that has a directional coupler or splitter here and one that does not. And read the particular manual for that specific unit. And I can talk about that a little bit. Amplifier level controls, at least in the Comcast world, most of the Cox systems I work in, everybody uses the automatic mode, regardless of whether it's aerial plant or underground plant. So there has to be a ADU present. All of Comcast is buying them with the 711 charter as well. Cox does the same. All 711 pilots, so they need 711 ADUs or QAM ADUs. Tone has to be available, to make sure the amplifier can actually control itself over temperature in the automatic mode. Your gain control mode selector would be an ADC, and you would get a green light telling you that the pilot's there and everything's working fine. And this is the recommended practice for most of the MSOs that I deal with. The Bodie board is basically a variable equalizer, and you can see from the diagram they're trying to explain here that it'll turn the amplifier up or it'll turn the amplifier down. Now, when I go back to this slide here, I talked about this U-turn. You can see what they're doing here is sampling the signal that goes to ports 3 and 4 prior to ports 3 and 4, and feeding an attenuator, which generally remains a 0 pad, hits the ADU, tells the gain control circuit what to do based on whether you're in the manual position. And again, you're setting up manually, and then you're going to move to automatic once you're happy with your manual settings. And then all you're going to do is take the adjustment for the ADU and just barely touch it to, marry up the levels you set up in manual. Nothing more. Don't try to overthink it. Everybody does. Again, this control is a 20-turn pot. You're probably only going to turn it, maybe a turn or two in either direction. If you turn it any more than that, then you probably damaged it, or somebody else has already damaged it for you. So we're going to go to forward setup. Here I'm showing test point adapters. These are the ones we sell. Here's the part numbers for those. Here's a part that Comcast buys, and they have a SEPA number applied to it. I believe that Charter has something similar. And the reason why you want to use these is simply because you have this little ring right here that creates a better ground. Instead of using just an F barrel, this is a whole lot better to look at, your signals, especially at the high end. You want to make sure that, this little sleeve is there. It just rotates around this thing. If it gets damaged or whatever, you probably want to get another ring to replace it. And this is a little bit, the ring is a little bit different. It has like 4 or 5 or 3 or 4 of similar type of raised areas on it, and it spins as well. What I like about these two is that they come in 4-inch and 5-inch, so you can actually poke through the the cover on the amplifier, through the lid. Here's a slide that I was asked to put in here, and here's what could potentially happen if you used an RF barrel, and here's if you used a the proper test point probe. And you can see that we don't have a suck out over here because of those little raised areas on that range. Hold on a second. Okay, sorry about that, guys. When she calls, I generally, it's something important, so. And it was. So is everybody comfortable with, getting a new probe and making sure that they're looking, proper test point and making sure that it's, well grounded and giving you a good connection? Some of the changes to this particular amplifier, as I mentioned earlier, the handle used to be on one side, so when you went to pull out the EQ, the board will lift up on one side. This board right here is centered, so if you go to grab the pad, it goes right up against the cover for that and prevents that from raising up on one side. Amplifier specifications, this is all outlined in all the manufacturers equipment manuals. Make sure you get familiar with whatever amplifier you happen to be using, and make sure that you've got copies of the prints and you got copies of whatever playbook you might need to make sure you're in the right area. With specifically, like Charter has a high split and mid, or a high split, they skipped over mid split. and they have also a playbook on subsplit. Comcast, you'll find that they have a playbook for what we call Tier 1, Tier 2, and Tier 3. Tier 1 is generally high output nodes feeding a string of taps before it hits the first amplifier, and there's generally only 2 amplifiers in cascade. So make sure you're well aware of that. Tier 2, and that was a transition from NGAN to what they're calling Genesis now for Tier 1. Tier 2 is basically business as usual. You're going to be dropping in and replacing the housing and the amplifier module itself in Tier 2 for Comcast. Tier 3, there's several variations on the theme, and that's going to be dictated by the local region that you're in. One thing I think is vitally important is when you go to a 1.2 gig amplifier, you can see these are designated CE 120s. One thing I want to point out is the CE 120 14 at let's say 750 has roughly 3 more dB of loss than a 1 gig 14 EQ. So you may find on the prints that, you're close to a +2 digitally, +8 analog. That's because you're trying to maintain a level above the noise figure of the amplifier. It's noise contribution to the system. So we want to be above that noise figure. If it's a digital level, again, it's going to be 2. If you dropped in and say you look at the print right now and it says it's a 5, you're probably going to be a 5 pad. You're able to drop that pad, or when you change the equalizer, it'll be roughly the proper level. But just make sure your inputs are correct. Make sure that when you look at the print and it shows that you're, say for instance you're a +2 right now, and you drop in a 14 EQ 1.2, and it used to be a 1 gig or an 870 EQ, you're going to see a significant difference in input level. And in the case of a 1 gig to a 1.2, again, it's a 3 dB difference. So make sure you're maintaining your inputs, and if you have problems, make sure you talk to your local team to find out how they want to rectify that. In the case of Comcast, guys like Frank Eichenlob and Bill Polis, back in Philadelphia, they work with these kind of numbers all the time. So they're generally aware of what goes on. Same thing with the charter team. They're constantly looking at how they extend their bandwidth and still maintain the proper amount of input levels and output levels from the amplifiers. Tilt chart. This is in the manual. I'm not going to point it out too much. It just shows the type of cable tilt. So that's inherent with cable equalizers. Cable simulators, pretty much the same. They do exactly what they say they're doing. They're simulating cable. So these are primarily used in short space areas, and that it's generally going to be called out in the design prints. So make sure you're very familiar with what's going on. Just don't walk up to an amplifier and start using your meter without realizing that somebody might have actually designed and told you what equalizer or cable equalizer or cable simulator you need. And you can see this has the exact opposite effect on cable tilt, the cable simulator, designated as CS in this case. All vendors, do this, and some of the newer amplifiers that are coming out will probably have an automated way of changing that without physically changing a pad.
Rich, I have a question.
Sure.
So for Ford equalizers, whether they're new or old, do they have any impact on the return band when we're going from a sub-split to a mid-split and a high split?
Yeah, you got to make sure that you're using the proper return equalizers. They'll be designated with N's or any, like a sub-split would probably be marked with an S, or it'll tell you that it's 5 to 85. Mid-split's 5 to 85. High split is 204. Goes to 204 on the return. Make sure you're putting the right EQs and you're pulling out the right, equalizer for that particular bandpass that you're trying to, maintain.
But the forward equalizer would not have any impact on the return. So if you, in a pinch, stuck an older, say, 870 equalizer in the forward, which you really wouldn't want to do because you may end up having to go back there and find it, but it would not impact the return band.
Not at all.
Okay, I want to make
what you would see on the forward path is probably a 3 or 4 dB increase in RF input level. If you went from a 1.2 to a 1, it'd be about 3, and if you went to 870, probably an additional dB. So in the Comcast world, it's something that Eichenlob and company came up with, where they want you to use all the same product in all the gear, based on what they determine should be on the BOM. So don't try to, if you have business partners out there that have different pad boxes and stuff, you may want to talk to them about that before you start deploying, so that they don't put a return EQ with the wrong bandpass in there, or on the downstream, the same thing. They don't want to use an 870 where it's recommended in an asked for a 1.2. And again, if you do have problems with input levels because you're having a problem with inputs to begin with, and then you drop in an equalizer that has 3 more dB of insertion loss, you're probably not going to make noise figure. So just be very cautious. Forward setup. I will try to explain this as easily as I can. I'm an old moto guy, or Gerald guy, so I think of these things a little differently than some of the other vendors. I'll try to describe both, but primarily there is a manual gain control on this amplifier. Some of the other manufacturers, under the CommScope umbrella, the C-Core and the Magnavox gear, there is no manual gain control. So generally you're looking at your input level to verify or to maintain your output levels. So if you get your input right, the automatic drive unit or AGC is probably preset, sort of in a middle point. And all you're going to do is you're basically going to know what the temperature outside is and determine whether you want to give it 1 more dB of signal because it's cold or it's hot outside, or take 1 away because it's warm outside or hot outside or cold outside. So in colder temperatures, your input levels are going to rise. You'll notice, like in the summertime, especially out where I live, the cable tends to want to sag towards the ground. And in the cold level, because the metal is expanding, so you get higher losses. In warmer weather or colder weather, it tends to go closer to the sky. The metal doesn't expand, it actually contracts, and you get higher input levels. So there's a chart down here for that type of determination based on the total loss, and then also what the temperature is out at any particular point. Now, the one thing I'll point out is most people don't have half dB pads. So you can still use this chart to set up the amplifier. You don't have to adjust the gain control. This is how we're training people now. It's not the way that I would normally train people, but it seems to pretty much be the same for most other vendors. That you basically get your inputs right, and then based on the ambient temperature at the time of setup, you look at a chart like this and you determine whether you're going to increase the pad or decrease the pad on the input, and then look at the outputs to see that you're actually making the outputs that are required for your system levels. And this is just a blown up chart of that. And this is in the CommScope mini bridger manual. Forward setup just continued. Let me back up here just a second. So it's recommended you remove the pad or the EQ or both. I don't like looking into an open, so I would probably want to just remove the EQ. Remove the powering fuse that powers up the amplifier. What you don't want to do is, if you're going to take the amplifier in or out of the housing, you don't want a spark to occur where your RF energy is at. You want that to, happen where your shunts or your fuses are at. What it'll create is a powdery dust, what we call, it's like a carbon dust that builds up and eventually creates like common path distortions. So get in the practice of not, pulling amplifiers in and out without pulling the power before you do it. If you pull the fuse that powers up the amp, there's no draw on the amp itself. It's not drawing any current, and it won't create a spark. So put the module in first, and then apply the fuse later. Make sure all your bolts are nice and tight, as we mentioned earlier. And this goes for all vendors. Install the design pad and EQ based on the design prints, and you should have those available to you at all times. Read the RFL levels at the input test point, and then install the proper pad and EQ according to input levels. And again, that's where you would refer to this chart, or this much larger chart here. You're basically going to connect a signal level meter. Once you do that, once you got your inputs right, you're going to look at the outputs. You're going to make sure that you're in the manual mode, and this is true of all vendors. You don't set up an amplifier in automatic prior to setting it up in manual. Always set it up in manual first. In this case, you would have a gain mode LED that will turn off. And understand, as I sort of mentioned, that the reserves are preset at the factory. So when I mentioned that some vendors don't have a automatic or the manual gain control, we're asking you to basically forget that there's a manual gain control that you can actually adjust. But in the event that you do have to get it back to where it needs to be, you turn it all the way up and you back it off based on this chart down here below. So most systems are operating or setting up at 1 gig now, and you can see based on temperature 32 to 110 degrees Fahrenheit, I would turn it all the way up and then back it off by 4 if I was at 1 gigahertz. If it was above 110, then I would, turn it down 3 from the top. But what we're trying to do is avoid that, just, take some of the control away from it. And, because they're already preset in the factory, there's no real need to do it. But if you do need to verify it, somebody else has been on the amplifier before you got there. Here's how you get it back to where it should be so that you can, set it up correctly with the temperature chart that I showed you previously. What you're going to see is, on the output is your input level, minimum full gain, and any excess gain. Your design input equalizer can be adjusted for more accurately setting the output tilt if you need to, but you want to make sure that somebody knows that you've changed it. In my practice, when I worked at Cox and TCI, we used to make sure that everybody marked up the drawings and brought them back to the design team and told them, I use this instead of that kind of thing. Just follow whatever procedures the local team wants you to follow. Here, I'm just pointing out the operational gain, and that's where we want the amplifier, oddly enough, to operate. So it has 47 dB of operational gain, which is where we want the amplifier to operate. It has 5 dB reserves at 1.2, 4 at 1 gig. You can see the potential gain is different from 1.2 to 1 gig. Here we have 5 dB reserves, 52 potential, but you're only going to want to use 47. Here you have the potential for 48.9 if you got rid of all your reserves, but you have to have that reserve so that that ADU, or the automatic drive unit, can adjust itself over temperature. If you turn it up all the way or you back it off all the way down, the amplifier has no way of actually being able to adjust itself to temperature changes on the input to the amplifier, the coax preceding the amplifier. And generally we use these again, we want most of our customers to operate in the automatic gain control, even if it's an underground location. You'll just find, over practice, that you maintain better stability in your system. The bottom thing here, we say additional attenuation may be used in the output pad location. Some systems don't want you to make a change to that pad. So make sure you're following whatever local procedures there are. Comcast, they have Comcast University. I'm sure Charter has training people that create their own documents. I got one yesterday that somebody asked me about, and I'm still under review of what they said they wanted to do, and they're asking me to approve it. I would rather have themselves determine whether that procedure works for their particular site, and that somehow they either go through their regional, divisional, or corporate people to make sure that they're following some sort of playbook on setup. Okay, so this is sort of an eye chart, but you can see what I did here was I set up things for sub-split, mid-split, and high-split output levels and tilts. So you can see I have virtual levels, which we used to call analog levels. Most systems are operating with digital levels now, which are 6 dB below analog. So in red, which is where I want you to pay most of your attention, is in the sub-split, your levels on the output are going to be more or less 49/32. And that's going to be determined by your print. So these numbers may be slightly different. But you'd have 17 dB of tilt from 54 to 1218. If we go further down here, you can see it's 45.8/32.2 because we're now in the 1 gig area. And your tilt is only going to be 13.8 because we're losing some of the forward bandwidth and giving it back to the return bandwidth. So you'll see a 45.8 at 1 gig, 32.8 on the low channel at close to channel 30, and there'll only be 13 dB of tilt because you're losing part of your forward going signals. Taking this 1 gig, grab this thing again. Here we go. At high split, you can see the tilt is only 10.8, again, because we're giving up part of the forward going bandwidth to the return path all the way out to 204. And of course, our levels are, a little bit different. 45.8, 35 at the low end. And that's because we're further up the scale on the, where that channel bandpass starts. It's not because the level has changed, down here with mid-split or high split. When you go up here, it's just, that's like if you went to a mid-split system and you were to measure 258, you're going to find that it's going to be 35, and that's just simply because we gave part of that return band or the forward going bandwidth to the return path. This is vitally important for everybody to understand. To again, make sure you got the prints, you're operating in the proper, you got the right amplifier for the right system, the right part of the the area, because you're not going to be installing all the amplifiers all in one day or even a week. It's good practice if you're going to do a node to do all the amplifiers in that node location on all four legs. That way you don't have any micro reflections because you have different band passes, and some of that signal that might bounce into a subsplit diplex filter may bounce back into the system and cause issues with pictures or even create potential outages and stuff. Now I know, Woody, you had a question related to this with diplex filters.
I typed it in the chat, so if the audience would care to read that and type your response, just type in A, B, or C, because it's a multiple choice question. I would like to also comment that setup becomes extremely important, and the reason is because OFDM is an extremely robust signal, so there's a high likelihood that operators, even though they might be limited to a gig or they may only show bandwidth up to a gig, there's a good chance that they'll start putting OFDM carriers higher than that. If your setup is wrong, then you'll start getting overdrive in your amplifiers, or maybe you're just low signal because the amplifiers, the tilt's not right. You're not getting enough gain at the high end. So setting up and making sure your response is linear between your high and low carriers is very important.
Yeah, it's vitally important. Don't balance on your pilot carrier. You know, that 711 megahertz. I've been to several sites where, you know, they're an 870 or 1 gig system, and somehow somebody told them that they should use that pilot carrier as their high reference carrier level. Your highest carrier is your highest carrier reference level. So if you're setting up at 1 gig, measure 1 gig. Don't measure 711 because you're going to be, you know, 3 or 4 dB low. And you're not going to pick, like in the case of a line extender, you're going to pick the wrong equalizer. You can either go real high with it or real low with it, you know, a dB or two, one way or the other. It's just good practice to look at the high reference carrier, the low reference carrier, and also measure that pilot level to make sure it's somewhere close to where it needs to be so that the amplifier can adjust itself over temperature. This is basically, you know, a summary that I put together, and I'm not going to go over it. It's just, you know, something to reflect on once you get a copy of this, and you know, you can review it. Covered this already. Again, most systems are going to be running an automatic, which means that they have to have an ADU present. You know, it has to be installed. Pilot level has to be maintained at 711, and you know, most cases with at least Charter and Comcast and Cox. Gain control mode selector is going to be an ADC. Once you get your manual gain control set up right, you're just going to move the ADC suitcase jumper, in this case for this amplifier, to the ADC mode, and then you should see a, you know, you're going to marry up the levels, and then you're basically going to see a good green light. If you don't see a blinking light, then you know you got an issue. I know that Comcast and Charter and Cox have not bought manual, and they're not using thermal gain control. They're not ordering them that way. There may be, you know, some systems out there that may do that though. So just be aware. And like what Woody was saying earlier about identifying what product you have based on the diplexer, you know, what bandpass it has, whether it's high, mid, or low or sub. You also want to make sure that, you know, you got the right amplifier in your hand, you got the right design prints, and if you see something crazy, make sure you call it out. I know in the Denver market, I work with Dave Kelly quite a bit. He's down in Houston now. And when we first started, they sent out design prints from the design house. Not going to pick on them, but they sent out design prints showing high split, and they were actually installing mid-split amplifiers. So all the design prints had to be changed, and that was, you know, relatively costly. So the design guys need to know, the management needs to know, the supervisors need to know, everybody needs to know what they're working on, basically. Make sure you guys are always talking and having good meetings on all this stuff. ADU setup, really simple. You got all your manual settings correct. You're happy with your high and low reference carriers. Your ADU is, you know, right on the, you know, money. You know, the pilot carrier is 711. Generally the pad does not change for the ADU. It's going to be a 0 dB NPB pad or a JXP pad. One was built by Eris and the other one was built by Gerald, and that's the reason for the designation. That's the J. The ADU will not operate below 34 at the ADU frequency. So make sure that you know that you've got to be above 34 to make it work at 711. And here's some of the nominal levels. So for 609, 40, and for 711, it should be roughly about 41.9 or 42. If you have to go higher than that because you have a frequency response issue, or I have a customer, I won't mention their names, so I can't remember. But if they had higher levels at that particular, if they wanted to run the amplifiers hotter, of course, it changes the range of the ADU or its ability to, change over temperature. So if it was above 45, you can see that's quite a bit of difference. That's a 3 dB difference. But it still would maintain a 0 pad. If you went to 46, it's just an increase of 1, 47 another dB, and 48 at 3. I just remembered the customer. It's Videotron up in Canada. They're running their output levels 3 dB hotter. And Comcast does the same thing and a similar thing. And I won't get into the details, but they do the same thing with Tier 1 in Genesis.
We do have another question, Rich. The question is there an easy way to check for a short with these mini fuses? Not much room for probes without making contact or shorting to the module. Coming from a simple C-core power pack and shunt fuses. Thanks.
Yeah, just be very careful. You can use the housing as the ground and just use your red lead to check either side. If you want to check the fuse itself, you can pull the fuse out and check with an ohm meter. There's lots of ways to use your meter, but if you're concerned about whether the fuse is working at 30 amp, it's basically a fuse, but we call it a shunt because it's because of the amount of how much power that we're trying to drive through that amp. Most of these amplifiers will maintain, you can maintain a 17 or about a 15 amp draw without any real problem. If you blow a 20 amp fuse, that might be a little bit of a nuisance. A 30 amp fuse, you're really going to have a nuisance, but or you got more than a nuisance. But as far as a short in the system, you just could pull the fuse and just, look to see if you can see a ground, between your hot lead and your the housing itself. I don't know if I answered your question correctly, but just be careful when you're probing the fuses. And then on the cord itself, you have a place where you can actually, you don't want to jam your lead in there too far, but you can also check to see if you got power coming in on this cord coming from the power supply and on this particular amplifier.
Since we're running up close to time, Rich, is it possible to skip ahead, kind of talk about the return path, the padding, and equalizer differences?
Yeah, that's where we're going right now.
Thank you.
So return path, you just want to ensure that your manual forward setup is complete and your auto forward setup is correct before proceeding. Connect the sweep system to the output node. Some systems are using the XM2 meters, so you're basically just doing a loop back from output to input. People that are using Viavi meters, they can actually sweep and use carriers to balance the return. And you often use telemetry signals, and they try to get close to zero as they possibly can. But please refer to whatever manual and instructions you have on any particular meter that you're using. I will mention for the high split folks that you want to make sure that you basically want to sweep the plant, on the return. You want to look at high, mid, and low carriers all the way, from 5 all the way up to 204, so that you're picking the right return equalizer. And you got a nice flat signal, and you're getting the right and proper output level. In the case of Comcast, and this is probably going to be different for Charter and the other networks, we're now asking people to put an ADB pad into the return path prior to the amplification and the amplifier itself. We actually created a new CIFA number for the Comcast folks that where the amplifier will actually come in with an ADB pad. And again, you want to make sure you're talking to the local team about whether that 8 pad needs to be a 6 or a 9 or what have you. But they found that on the NPR curve that an 8 is where they wanted to be. Other systems, like some of the guys in Canada, they're using 10 pads. I know guys that are using 6 pads in the return path. And again, some of these amplifiers come with 24 dB gain return, others come with 27. So that's going to make a big determination. The Charter folks right now, they're buying all high split 1.2 gig amplifiers, and they'll come with a 27 dB gain return amp. So that's why I'm warning you that you may not want to use an 8 pad. You may need to use a higher value pad or a lower value pad, depending on, you know, what your corporate office is recommending. Woody and I got into this because one of the guys, you know, that work with him up in the Bay Area, they read through Comcast University, which is required training for Comcast employees. And when they did, they recognized that they had not been putting the 8 pads in. Some guys were and some guys weren't, from what I remember, Woody. But it's recommended that they use the 8 pad because they're trying to get somewhere, you know, a little bit more comfortable for the Comcast engineering team in Philadelphia to be happy with performance. And they're, you know, they're all using the 8 pads out of the box. And again, they may need to change that depending on, you know, what goes on in that particular part of the network or region. Reverse sweep versus balancing, and this is probably where I'll leave things. It's just the difference between whether you're using an XM2 meter or a Viavi meter and actually sweeping the plant. With the XM2, you're basically just doing a loop back from output port to input port, or, you know, back to the return, back towards the head end in each individual amplifier with like the Viavi type meters. There's other companies that sell similar meters. You're basically looking at reference carriers, you're looking at telemetry, and you're making sure that signal is balanced, again, from 5 to 85 or 5 to 204. It's good practice to sweep. Return path alignment, and here I'm just showing an example of low versus high. You guys can review this later because we're short on time, but you can see that there's about a 6 dB difference between a low split and a high split, and that's because of the amount of return bandwidth that's involved. Don't want to overdrive any digital transmitters or any type of transmitter to ensure that you're not overdriving things. And here's an upstream channel layout. This came from the Charter team. I just tried to mix and match Charter and Comcast because I understood that most of the people on the call would, you know, be from one of those two companies. But this is just sort of what would be broken down in the return path, where you have the diplex filter from all the way up to 204 on the return, and then, you know, there's an area where there's nothing really going on. It's a crossover network, and the forward going signals would start up at 258. But here shows, you know, some SQAMs, some OFDM block 1, 39 to 108, 90, and here's another block of 96 to, or a 96 megahertz, a block of 108 to 204. And then there's some, what they call exception zones that they drop in. And that just is based on a lot of different things, like, you know, how well have you maintained your plant. I'm not trying to get ugly or anything, but the one thing you learn from working on, you know, some of the 40, 45 amplifier cascades. I worked at Cox, you know, back in the early 80s, and we had a sub-split system for the A cable, and then we had, and the amplifiers went out to 450 megahertz, and the amplifiers on the B cable went up to basically channel 7 or 8. It's right around 174 megahertz, 175.25, and we had to be very cautious about how we handled, you know, making sure the guys didn't mix and match amplifier housings, as you know, or amplifier modules, so that they didn't lose the low band, but as well, they didn't want to, cause any issues with making sure that they're maintaining everything throughout the whole entire network. So where I was going with this is if you had a 40 amplifier cascade, setting up the return, what we used to say is that's where all our dBs come from. And we weren't talking about decibels, we were talking about dollar bills, because we were at that particular point, we were starting to use addressability. And, if people bought pay-per-view or anything else, they would have to, want to recover information from the set-top boxes so they could charge a customer for whatever pay services that, he was buying. And as we got further and further out into the system, of course, the guys way out at 40th amp didn't have near the kind of signal level you would have, 2 or 3 amplifiers, away from the head end.
I would like to make a comment, Rich, and that is, we don't have to go back to the slide, but when we talked about putting that 8 dB pad on the input, I was told to me that some of our Canadian friends went to launch a OFDMA, and they had 0 pads on the input of their amplifiers, and they soon found out that everything went into compression. They ended up taking the OFDM A off, and then they went back out and repadded the inputs to all their amplifiers. So for everyone, if you have a playbook or a design, make sure you follow it closely and make sure you get the right pads and equalizers in the amplifiers, especially in the return, but the forward as well.
Good point. And then just briefly, you may run into a triple. And a triple, like I said, let me just show you a block diagram here. Down here, where we would normally put in a directional coupler or a splitter, right here, there is a splitter, but it's fixed underneath the cover. And what they did was they provided a little bit more level to this gain stage, the same that they had with the standard mini bridger here, and they got all outputs being the same. Whereas when you put a directional coupler or splitter in here, you're either dropping the signal by 3 dB with a splitter or 8, 10, or 12 with a directional coupler. So if you run into this amplifier, you may want to check, and you're trying to install it and it's calling out for you to put a DC in there and there's no place to put a DC, you probably have the wrong amplifier. I've had a few calls about that in the last couple weeks. Here's a lot of the ordering matrix stuff. There's some new SEPA numbers, and that all has to do with whether there's an 8 pad. So if you see a model number or a new pin, here's the SEPA numbers over here for the Comcast folks. You can see that there's an 8 designation for all of these right here. And that just tells you there's an 8 dB pad in the return. We haven't done this for other companies because, like what he was mentioning about Rogers and those folks up in Canada, they've chosen to use a 10 pad, but they're actually inserting those themselves rather than asking us to do it. How much time do we have?
Just a couple of minutes, 4 minutes.
So I'm gonna skip through most of this, but because this is repeat. The only real difference here is purple versus red in the line extender. If you buy the BLE 1.2 gig amplifiers, make sure you look at the other vendor equipment to make sure that you're not just putting a new amplifier in an old housing and not being able to get the right amount of bandpass. Most of these slides are very similar in nature. The output levels are the same. All these charts are the same. The main difference here is the amount of operational gain. Instead of like 45, instead of 45 here, you're only getting 38 out of a line extender, and that's because of where it sits in the system, and you don't need near as much. Well, I won't get into design principles right now, but just keep in mind that line extenders have a requirement for more input level to get the same output level out of like a mini bridger or a bridger amplifier. Same chart as I showed you before. Output levels don't change. Make sure you refer to the prints. ADU is set up the same, and the return path is all the same. Even the suggested, accommodations for OFDMA, again, playbooks, all this stuff is, going to be different from vendor to vendor, or not vendor to vendor, but MSO to MSO. So again, what he was saying about playbooks, what I've repeated over and over again, playbooks, design prints, manuals. On the line extender, and this may be for everyone now, but there are different variations on the theme. And I'll get into that here in a second. Most of the amplifiers now have the need for you to cut off these two plastic legs, depending on what vendor you're buying your components from, your accessories. You may or may not need to cut off those if these little plastic guides are in place or not in place. So this, you would probably want to leave the blue plastic guides in. With this one, you cannot, because it's this little plastic piece here is occupying the two holes for those two pins that pop down that you're going to cut off. So let me back up here just a second. I have one other change here. I'll show you. I have it. But there are two different line extender power supplies. Just be aware of the model number that you have. If you're a Comcast employee, still, yeah. And understand that some of the startup voltages are slightly different with one line extender to another, and that all happened during COVID and supply chain issues, and we used other components to basically, get everything moving in the right direction with the upgrades. Startup voltage is usually around 38 for a line extender, and the one we replaced it with, which doesn't have a replaceable F-Tech, I think the startup voltage is probably closer to like 42 or 43 volts. So if you put this out, in a rural area and you don't have that much voltage, there's a good chance that amplifier might not fire up. There's not much chance that you're going to see this unless you're in like mountain areas of Colorado or some rural area. So just make sure you know the model number of the line extender that you have for the power supply. That's pretty much all I have on this stuff. Just make sure if you guys have any questions, to submit them. I will make sure that Woody has copies of this particular presentation. The only thing I require from anybody right now is to, maybe give me a head count of how many people were actually on the call. Comcast tracks that very carefully, and they want to know exactly, how many people, took the training. If it was up to them, they would know, your street address and phone numbers as well. But
Rich,
I'm just going to
when we get the attendance report, we will share how many.
Yeah, anything you can provide to me as far as like who attended would be great on the Comcast side. Charter, if you could just give me a number of employees, and if you can provide names, that would be great too. But we just want to make sure that everybody's aware of the Comcast, especially wants to know who attended. They have a project manager that actually tracks all that information.
Okay, Rich. Well, I just want to say thank you for delivering this important presentation. I hope everybody got a lot out of it, just as I did. And we have another presentation on, I believe it's on PON in September. So please look out, check your email for details about that, and we'll talk about PON. So Thank you very much, audience, and thank you very much, Rich. Appreciate everybody attending. Everybody have a wonderful and safe day.
Thanks, Woody.
I'm having trouble finding the end.
Yeah, me too.
where to end the presentation. So bear with me for a minute here while I figure that out.
Yeah.
Found it. So thank you, Rich.
All right, you take care.
You too.